Welcome to our last unit of the year, and this is going to be one that maybe you're familiar with before, arithmetic and geometric sequences and series. So this first week we're going to focus on sequences, both arithmetic and geometric, and then we're going to move on into series, and there's a little difference between them, just what it's asking for and the formulas that you use. So we will start first with arithmetic sequences. So first off, what is an arithmetic sequence? It's just a list of numbers, so let's start with that. A list of numbers, and there's going to be a pattern to them, and every consecutive pattern is going to be separated by a common difference. And so I'm going to say separated by a common difference. And I'm going to make this maybe put more in layman's terms for you. Every term is either adding or subtracting by the same amount. So we're just going to say it's adding or it is subtracting. And we're just going to be focusing on the adding one. If it is subtracting, you're just adding a negative number. So everything is going to be adding by a common difference every single time. So first examples, these are going to be really simple for you. Determine what the common difference is. So to get from 300 to 350, what is it adding by? Pretty simple. It's adding by 50. And we can double check each of these terms. From 350 to 400, it's again adding by 50. From 400 to 450, it's once again adding by the same thing every time, adding by 50. So there's your first common difference. For the next one, it's going from negative 12 to negative 14.5. So it's actually subtracting. So your common difference will be negative. And how much is it going down by? It's going down by 2.5 each time. So there is your common difference. So go ahead and try the next two on your own. I'll give you about 7 seconds of wait time to do those. All right, hopefully that was pretty painless for you. Let's move on to the next example. So this one says, determine the common difference of the following arithmetic sequence. So we have your first term here, and then here's the second term, the third term, the fourth, the fifth, the sixth, and we also have the seventh term. So in this case, we're given the first term and we're given the seventh term, and I want to find the common difference between them. So here's how I do this. Think of this kind of like 2 points on a graph. We know that the first term has a value of 13, so I kind of write it as a coordinate. We also know that the seventh term is 23.8, so I know the seventh term is 23.8. If I want to find the common difference, it's kind of like finding the slope. So we can use the slope formula that I'm sure you've not used in a while, but it's 23.8 subtract 13, y2 minus y1, over x2 minus x1. And if you subtract those, you get 10.8 divided by 6, which gives you 1.8, and that will be your common difference. Now let's just kind of look at what we just actually found. We're starting at this 13, and it's jumping up once, twice, 3 times, 4 times, 5 times, 6 times. It was adding 6 of those common differences. That's 6 of those. And to get from 13 up to 23.8, it jumped up by a total of 10.8. So if it jumped up by 10.8, but it took 6 different jumps to do that, each jump is worth 1.8. So if you wanted to, you could double check your work. You could add 1.8 here and you'd get 14.8. And you could keep adding 1.8 until eventually at the end it would work out to 23.8. So go ahead and try the next one on your own, and then come on back and we'll make it just a tiny bit more complicated. All right, welcome back. Hopefully that one wasn't so bad. So the next example, it says the first three terms below represent an arithmetic sequence. So we're adding by the same amount every single time. And then it just says solve for A. Now this one, you could probably be clever enough and do it in your head without really showing any work. We're showing a simple example just so you can kind of see why the formulas are going to work. So most of you would probably be able to look, oh, here's 14, here's 22. The A has to be right in the middle. A is going to be equal to 18. Okay, I get you know how to do that. But let's show mathematically why it works. If we take A minus 14, that would give us the common difference between the first and second term. But I also know that that common difference should be the same as going from the second to third term. So if I take A minus 14, it should be equal to 22 minus A. Let's write that out. A minus 14, that gives you the common difference between the first and second. And that common difference has to be the same between the second and third term. 22 minus A. Before we solve this, I want to go up a little bit and just show you a simpler example. If we look at this earlier pattern of numbers, if I took 350 minus 300, that's 50. That 50 should be the same as 400 take away 350, and it is. So we're setting those common differences equal to each other, and now we can just solve. So we can add A to both sides, and we get 2A minus 14 equals 22. We can add 14 to both sides, and we get 2A equals 36. And if you divide by 2 on both sides, we get A is equal to 18, which is what we kind of figured out earlier just by looking at it. So this A would have been 18. You can always double check your work. To get from 14 to 18, it's a common difference of 4. And from 18 to 22, common difference of 4. So it does work out, and it is arithmetic. Now let's try one where it's a little bit more difficult, but we're going to use the exact same process. The common difference between the first term and the second term, to get from 14 to A plus 5, we can just subtract them. So I'm going to take A plus 5, that's the second term, and we'll subtract the first term, which is 14. And that would give you the common difference. But that common difference has to be equal to taking the third term and subtracting the second. So we're going to take 3A minus 10, and we're going to subtract A plus 5. Those parentheses are very important there. If you just put minus A plus 5 without the parentheses, that 5, hopefully you'll notice, will end up becoming a negative because of that subtraction. Let's simplify this. A plus 5 minus 14, that just simplifies to A minus 9. And over here, if we take 3A and subtract A, it becomes 2A. And if I take a negative 10, and remember this becomes a minus 5, it will become minus 15. And now we have to solve it. Let's subtract A from both sides. We get negative 9 equals A minus 15. And if you add 15 to both sides, we get A is equal to 6. So it's probably going to be a good idea, just double check your work. Let's replace the 6 back into the original values. If I put a 6 in here, 6 plus 5 gives you 11. And if I put a 6 in here, 3 times 6 is 18. 18 minus 10 is an 8. Let's write that a little more cleanly. So we go 14 to 11, that's going down by 3. And 11 to 8, it's again going down by 3. So it does work out to be an arithmetic sequence. So go ahead and try the next one on your own. You're going to have lots of parentheses, lots of distributing. So make sure you're careful with those. When you're done and comfortable with that, come on back. Okay, in the IB formula booklet, they're going to give you this formula. You don't have to memorize it or anything. The general formula to find the nth term in any arithmetic sequence is U sub n. That's the value of the nth term. is equal to the first term, u sub 1, that's the value of the first term, plus n minus 1 times d, the common difference. So let's see how this formula works with a couple examples. First one says, given this arithmetic sequence, 13, 19, 25, so on, so on, so on, find the 23rd term. So if I want to find the 23rd term, then we're going to start with u sub 1. So u sub 1 up here, that's our first term, which is 13. So the 23rd term would be equal to the first term, which is 13, plus n minus 1. In this case, n is the term number, 23, minus 1, times the common difference, which is 6. Then it's just a matter of simplifying. So if I take 23 minus 1, that becomes a 22 times 6. We can simplify 13 plus 132, and if you add these together, you get 145. So the value of the 23rd term is 145. It's a little bit quicker to do that than it would be to list them all out individually. I do just want to kind of show you why this formula works. You're starting with 13. That's your first term. Then you have the second term, third term, fourth term, fifth term, and so on and so on and so on until you get to the 23rd term. So here's our first term, here's our 23rd term. Every successive term is jumping up by 6. So that's why the next one's 19, the next one's 25. If I want to get from the first term all the way to the 23rd term, how many of those little jumps of 6 do I have to make? 22 jumps. So even though it is the 23rd term, we already started with the first term. So that's why we are jumping up 22 times, and each one has a value of 6. So those total jumps result in 132. Add the original 13, and we get to 145. So hopefully that formula makes a little bit of sense for you. Let's go ahead and do one more example. Find the number of terms in the following arithmetic sequence: 84, 81, 78, and so on. And the last term we know is negative 21. So if we use this, our u sub n is now going to be negative 21. Our u sub 1, that's our first term, that's going to be an 84, plus, we don't know how many terms it is, leave n by itself, and your common difference is negative 3. It's going down by 3 every single time. Now it's just a matter of simplifying and solving, so let's go ahead and simplify. If I take negative 3 and multiply it to both of these, this becomes minus 3n and plus 3. We can combine 84 and 3, so negative 21 equals 84 plus 3 gives you 87 minus 3n. We could subtract 87 from both sides, and we get negative 108 equals negative 3n, and divide both sides by negative 3, and we get n equals 36. So there would be 36 terms in that sequence. If you're ever asked to solve for n will always be a positive number. You can't have a negative number of terms. Running out of time on this one, so you're gonna have to have one short little video just for that last example. Sorry about that. So click on the next video and then you can finish.